Okay, so I figured out how to do something kind of cool, and I want to share it with you. In a couple of my previous videos, I talked about how I made a procedural dungeon generator using parallax mapping in RPG Maker VX. And that was pretty cool, but there's a problem with it. And the problem is how collision data is stored. So, for example, this is one of the rooms in my procedural dungeon generator in one of my dungeons. And what the game does is it takes, a series of images like this and it stitches them together on a base image based on certain criteria to make sure that the rooms are properly connected and that there's no weird isolated sections. The problem is with how the game stores collision data. And how it used to do it before was basically like this. It took a massive string of numbers, where zeros basically represent that it's impassable. 3 represents that it is passable but nothing can spawn there. 2 represents that it is passable and chests can spawn there. 4 represents that it is passable and players, monsters, or mission objectives can spawn there. And that basically makes it so that you can't get two things spawning in the same room that are critical events. And then a 1 represents that it is passable and any non-critical event can spawn there. That was how collision data was determined before, was with this massive string of numbers. And what I would do is I would take this and I would paste it into the file name. So the first character would be the room configuration, indicated by a letter either A to Z, followed by the collision data. This worked, and it was fine, but the problem, it was actually pointed out by a commenter on one of the videos. He mentioned that you could run into a max path error that plagues Windows, or basically the file name is too long, and you can't store that file there. And I didn't really think too much of it, because I figured, I haven't run into this issue yet. I don't think it's going to be a major issue. I'm not planning on my rooms getting much bigger than this, so I don't think it's going to be a problem. Well, I ran into that problem, not here, but at my job, where I ended up trying to download a file that had a file name that was too big for where it was going to be stored. And the thing is, the task that I was doing at my job was way simpler and way less strict than this. I could just rename the file name and it was no problem, but if you tried to do that with this game, it would break. So I figured, okay, if I've run into this issue doing a much simpler task, I need to find a solution for this potential error with this game. So what I have done is found an alternative to determining collision data for my rooms in my procedural dungeon generator. And I want to share with you what I did. So what I discovered was a method that you can use that I've actually used before in other scripts that I thought I could implement here, and I did, and it works really well. And that's a method called getPixel. What this method does is it takes a bitmap. In this case, what I basically used, I'll get to that, but it takes a bitmap and it finds the color of a pixel at a specific coordinate. And what I figured out was that you can basically store map data, you can store collision data in an image file by using specific colored pixels. And so what I did was exactly that. So this was what the image looked like before, and this is what it looks like now. As you can see, there's a little thing in the corner here. The image is a little bit wider. It's actually 9 pixels wider. That's it. And there's something in the corner. So we're going to zoom in on that. And this is what's in the very corner of this map now. This is my collision data. The pixels in the corner here are actually just a palette. They don't get read by the engine at all. I just use that to put together the collision data. But what this does is gray pixels are impassable, blue is passable and non-spawnable, green is passable and spawnable for non-critical events, red is passable and spawnable for chests, and purple is spawnable passable and spawnable for players, monsters, and mission objectives. So what the game will do is when it finds a room that it wants to use, it will take this room, it will do the block transfer for just this section, and then it will go into the corner, and it will go through every tile, not pixel, but tile in the room, and it will correspond to that with a pixel in the corner. And it will take the pixel color data, and then it will read that, and based on the color data, it will actually update the collision. So the way it works here is it will go through all the tiles in the room, it will get the pixel data at the specific coordinates, and if it is purple, it'll update it to the purple data, which is player spawn point. If it's red, it will update it to the yellow tile, technically, which is the chest data. If it's green, it will update it to the green tiles, which are basically, anything. And then if it's blue, it'll update it to the blue tile, which is passable and non-spawnable. Now, the cool thing about this is that because I established the rectangle at the beginning as to what I actually wanted to do the block transfer with, I can store that data without it actually showing up in the game itself. So I'm going to demonstrate that, and I'm going to show you what that looks like. Let's try going full screen here. So what I'm going to do, I'm going to demonstrate this first up. That this is the only map that I've actually updated the collision data on so far. It's the only room, so it's going to look a little bit weird, but I will demonstrate for you how this all works. I've set up the generation to make it so that it only generates this one room. And here we go. We are in our dungeon. And as you can see, collision data is working. We've got chests spawning in the right spot, monsters spawning in their own rooms, and exits spawning in basically any viable spot. Now I'm going to turn on a debug mode and show you what's going on in the background. So this is what the game is actually putting together. It's going through every tile, it's reading those pixels in the corner of the room, and it is replacing the tiles with the proper collision based on what was in that image file. As you can see, it looks pretty similar to that thing that I showed you in the corner there. So the blue is passable and non-spawnable, yellow is passable and spawnable for chests, purple is passable and spawnable for players and monsters, and green is passable and spawnable for any non-critical event. I don't have the non-passable tiles set to a specific color because there's not really any need. The game automatically starts by generating a room full of impassable tiles, and then it just replaces the ones that it needs to. So this is how collision data is now determined in Thrall with procedural dungeon generation. No more massive file names. I can actually name this file A1 for room configuration A, variety 1, and that's it. It's just 2 characters long, and all the collision data is stored in a tiny, tiny series of pixels in the corner of the map. And as you can see, those pixels are nowhere to be found because they are not getting transferred over with the block transfer. So that is how collision data is now set up in Thrall. I'm pretty happy with this as a result. I think it's going to be much more effective than what I was doing before, and I don't have to worry about running into that max path error. And, this is kind of the cool thing, is that one of the things that I like about being a developer is finding creative solutions to problems. It's not just, oh, it's good enough. No. It's good enough for you. Is it going to be good enough for everybody else? You gotta take into consideration, okay, is this going to potentially run errors on somebody else's system? And how can I make this as clean and efficient as possible so that it's as accessible as possible to everybody? So this is the new method of collision detection for my procedural dungeon generator in Thrall. This here is all the collision data for this entire room. I do need to get to work on replacing the collision data for the rest of the rooms. This is the only one that I've actually had the chance to do it with so far. But yeah, this entire room has its entire collision data determined by this little thing in the corner. So that's it. yeah, that's it for this video. I thought this was kind of cool, so I thought it was worth sharing. But anyway, that's it for now. See you next time.